Hello everyone. Let's discuss the topic stereogenic center and chiral center. These two terms are often mixed up in organic chemistry. But before going into the topic, first let us know what are stereoisomers. Stereoisomers are compounds that have the same molecular formula and the same connectivity of atoms but differ in the spatial arrangement of their atoms or groups in three-dimensional space. Stereoisomers are of two types. First one is the enantiomers. Enantiomers are the stereoisomers. They are non-superimposable mirror images like R and S lactic acid. Here you see you cannot superimpose S lactic acid on the R lactic acid or the vice versa. The second type is diastereomers. Here the stereoisomers are not mirror images of each other. They differ at one or more stereocenters. For example, cis and trans 2-butene. Like here you see the cis 2-butene and trans 2-butene have different dispositions of hydrogen atoms and methyl groups. Now you concentrate on the carbon atoms of S lactic acid or R lactic acid. Here you see this carbon or this carbon are connected to the four different groups. Okay, this type of carbon atoms are called chiral carbon atoms. But here you see this carbon means the carbon atoms involving in the double bonds are not connected to the four different groups. They are connected to the three different groups but not four. This type of carbon atoms are stereocenters but not chiral centers. Okay, so this concept will apply to define the chiral center and stereogenic center. First one is the stereogenic center. A stereogenic center, also called a stereocenter, is any atom in a molecule where the swapping of two substituents creates a new stereoisomers. For example, here as I said earlier, for the cis 2-butene and trans 2-butene, if you exchange any of the two atoms or groups, then they will also produce another stereoisomer. Okay. Next is the chiral center. As I said already, for the S lactic acid and R lactic acid, when the carbon atom is bonded to four different atoms or groups in a tetrahedral arrangement, then that carbon atom is called chiral center or chiral carbon. Chiral center is a specific type of stereogenic center. Why? You take this example. Now you see if you exchange any of the two groups in S lactic acid or R lactic acid, then they will also produce some stereoisomers. Okay, so these carbons are also stereogenic center, but at the same time they are also chiral center. But here they are only stereogenic center but not chiral center. So we can say that all chiral centers are stereogenic centers but not all stereogenic centers are chiral. Okay, so we can sum up this discussion by this table. Thank you all for watching my videos.